Hello, this is Jack Jackson. In this video, we're going to talk a little bit about using text boxes in GeoGebra and how to do some things like include some dynamic text in there and maybe some LaTeX typesetting. First of all, I have a text box here that I created. Um, the basic way to a real basic text box is you just click on this uh, drop-down menu here and go to where it says ABC Text. Click here, and you can type some text there. And that gives you just a real basic text box. You can modify it a few different ways. You can go to here and go to, well, a lot of things that you can normally do, like change colors. You can also go to text, and you have basically two options. You can have a serif text like that, or a sans serif text like that. You can do italics, again, with either of those options. You have several sizes: extra small, very small, small, medium, large, very large, extra large, and you can customize a size there as well if you want to control the size of that. You can also do bold or not. Okay, so those are the most basic things about a text box. Okay, but to show how we can do this with a little bit more advanced features, let me make a right triangle here. Let's incorporate this with, say, the Pythagorean theorem. So to start with, let's maybe make a text box here that says Pythagorean theorem. And let's make it serif and bold, which I can do from right there. And let's make it a little bit bigger, going over here and let's do medium. Okay, now let's create a right triangle here. Of course, you want to do this move tool to get you started again. So let's start with any 2 points and make a line segment. Now I want to make a perpendicular line to this, so we're going to choose the tool perpendicular line. So I click on that point and that line, then select a point on that line. So if we've done this correctly, C will not move off that line, but it can move anywhere on it. And then use our segment tool to finish up this here. And let's go ahead and just hide that particular one. So now we have a right triangle. What we might want to do is measure some angles here. Okay, there's that angle. Measure this angle and measure this angle here. All right, now if you notice, this didn't measure the angle correctly. It measured the going around the other way, angle bigger than 180 degrees. So what we want to do is all three of these actually. We want to take them like this, and under basic here on settings, select between 0 and 180 degrees. Okay, so we have these named. You know what? I think this would be better. If that's going to be angle beta, let's rename this point as the B point and this point here as the C point. Okay, so whatever, it doesn't matter how they're labeled. So we have that. We now have a right triangle. Actually, we really probably want, if we want to go with the more standard labeling, we want where the right angle is to be C, actually. And then this would be, let's go back to B on this one. Okay. Now, this side, the length of this side here is opposite angle. Let's see, this is A. Okay, so the angle, the opposite the angle at A is going to be this side, And let's go ahead and rename that. And a couple ways I can rename it. I can go to here and work with renaming it, but I can also go to the settings over here, and let's name that side A. Let's name this side C, and let's name this side B. Okay, now I can go to here, 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 and I can say, I can show the label, which is just going to be the letters A, B, C. I can show their value, which in the case of a line segment, it's its length, rounded to, looks like 2 decimal places here. I can show a caption. I can show a name and a value or a caption and value. So let's do name and value right there. Now notice that these measurements are dynamic. And because I've labeled them this way, the value of this is, well, C is actually this line segment, but it's also its value. Okay, so now how about some text boxes? That's what we're trying to do. Oh, by the way, let me show you something else before I go any further. If I scroll in or out, notice that these are changing position. Well, why did my one up here not change? And how can we make this one where it won't change? I can lock that object and then pin it to the screen so it doesn't move around, and I can't move it around without changing that setting. Okay, so here we have us a dynamic right triangle. Okay, now let's do some text boxes. So let's illustrate the Pythagorean theorem, which is a squared plus b squared equals c squared. So let's go ahead and go into making a text box. And the first thing I can do is just type in a square. Now, if I want to do some typesetting like powers or square roots or other types of things, those are actually LaTeX formulas. Okay, so if you know LaTeX, you can enter in LaTeX commands. Click on this box here, we'll make it a LaTeX formula. There are other sources you can go to for a list of LaTeX formulas if you want to get a little bit more advanced, but there are several basic ones that are built in here. And if you look, here are some. There's a formula, there's a fraction, a superscript, a subscript, square root. We may use that one here in a minute. Some different combinations. There's some marks here for things like line segments, underlines, overlines. That could be that for array, that for a line, and some other different things that are built in. And you can use pretty much any LaTeX command will also work here, besides just the ones here. These are just the ones that they think may be used a lot. So here's the LaTeX command for a power. It's just a to the power square plus, and then let's do b. Let's just go ahead and do this. B square. And Pythagorean theorem says that's going to be equal to c square. Okay. Now if I hit the preview, you're going to see what that looks like. It looks like just like that. Okay. So if I click it as that, we get that. Okay. Now, all right. Now what I want to do is I want to put the values of this in there. Okay. So I can put parentheses square Now, if I know the command, I don't have to go back to that menu anymore now that I kind of know what it is. But now this time I don't want A in there. I want the actual value of A. Okay, so this is kind of cool. So if you click on this little GeoGebra icon down here under Advanced, remember, press Advanced to see that, you will see the objects that we've created. Okay, now A is the length of that side A, so it will go there. Now, when I do the preview, it will have that value. Okay, notice it is also on the same line. Okay, in LaTeX, if you want to get to the other line, you do 2 slashes like that. Okay, so now we have a square and then plus. I'm just going to copy this. Control C, Control V. Whoops. Oh yeah, it doesn't, I'm sorry, it doesn't copy and paste very well. So never mind on that. So here we go. And then we want B there. And we want square, so we do power is going to be 2 equals. And then let's go ahead and put C square. Like that. Now, whoops. Okay, so we want B in here. Again, find that from our list here, B. And here we can put in C. So it's going to look like that whenever we hit OK. Where did it go? Did not like something. There it is. Okay, now that's showing the LaTeX formula. That should typeset it right correctly. Let me see if I can figure out what's going on here. Okay, it looks like when I'm pressing the serif button, it shows up correctly. Okay, so there it is, and notice that it is dynamic. So notice as these change, those values actually change. Okay, let's go with this just a little bit more. What is a square? Okay, so now if I type it like this, I can type in, say A, but now I can double click on that box and say caret 2 will be squaring. So now that will be the value of a square. I want it on the next line, so I need to put the slashes there. And I can say plus b. I could even start with an empty box like that and type in the formula that I want. So there's a squared plus b squared equals c squared. And again, I can start with the c here. And then let's actually work this out as a squared plus b squared. So I'm just going to start with an empty box and say a squared plus b squared. So that's actually going to compute it by actually adding those two squares together. And of course, then what we hope is that should be equal to c squared. And so that shows the computations there. Of course, you could check those with the calculator or by hand. They are rounded off, of course. But you can see what's going on there with this. And everything is dynamic. So as this thing moves around and changes, those numbers are updated to go with the measurements. But no matter where we put it, a squared plus b squared does equal c squared. So the Pythagorean theorem it holds and it's illustrated. Another way we could look at this is as essentially with the distance formula, the Euclidean distance formula or metric that we have there. So basically we could solve for c. So we could say c equals a square root, and I can go here for this LaTeX formula, square root of what? Well, it's a square plus b square. Okay. Now let's fill in the rest. So C is the square root. This time I'm just going to type it in, and it's going to be A. Come back to that in just a second. Square plus B. We'll get to B in just a minute. Square. Let's go ahead and put those in braces. And then that closes the square root. Let's get this where I need it to be. This one needs to be in braces. And then I need to put A right there. So this time it'll be the value of A. So remember that goes to here, A, and this is B. Okay. And then C equals the square root of, now we're going to put in the value of A squared plus B squared, and we're going to do that by starting with an empty box. And in that box, I'm going to put A squared plus B squared. That should be the value of A squared plus B squared, which is the 332.14 at the moment. And then finally, C equals, go ahead and give the decimal version of it. Again, we'll start with an empty box. Typing on that box, we can type in square root of A, the value of A squared, plus the value of B squared. And so there we have that typeset for us. All right, something's off a little bit because that is not the correct value for that. So let's try that again. So let's see if C, yeah, C worked out right, but something is wrong here. Okay, so it's, oh, right here, yeah, that's the wrong formula. A square, and then plus B square. Let's see if that's a little better. Yes, that's better. Okay, and again, of course, you can move this around. You can make the font bigger, smaller. You can change the color of the whole thing, boldface, whatever. So you have a little bit of control over that as well. So there are a couple text boxes, and once again, they are all completely dynamic there. So there's some basics of text boxes. Let me show you one more thing about text boxes that are kind of nice. There are a lot of special symbols, and I didn't show you this particular one here. If you know the LaTeX formula for symbols, you can get to them there as well. But for example, here I could look at the angles. So there's alpha, there's beta, gamma. We can look at some Greek symbols like uppercase delta. There's an infinity symbol, some relational symbols like subset, less than or equal to, not equal to. There's a degree symbol that comes in handy. Pi, might use that one a lot. You know, some different basic things here. Here's a symbol I like to use for angles, congruent. So a lot of basic symbols that you will end up using. Here's a lot of different arrows that you might use. Some other symbols that maybe we won't use as often, but there are a lot of basic symbols here that we can use, and those can be inserted into your text as well, right? So we could say that the measure of, for example, measure of angle C is 90 degrees, always, right? The way we've got it set up. I didn't do that by measuring. I just know that it's 9 degrees because of the way I constructed it. So, yeah, there's some things about text boxes, and join us back for some other videos later on how to work with GeoGebra.